Okay, as we begin probability and statistics in this course, first thing I want to start out by saying is I wrote this E of x discrete. Like, what the heck? E of x it stands for an expected value. Okay, if something were to happen multiple times, like looking at this word problem is a great example here. Talking about accidents per week, like how many accidents could we expect given this data? Sometimes they use M. Depends on the text, really. You know, this A1 times P1, we'll look at that with an example as well. The V of x, what I have listed next is variance. It talks about like how spread out the data is, and so does standard deviation, which is the square root of that result of variance. And that will make some better sense with this first example here. And last, like what I said, what is discrete? So there are discrete random variables and there are continuous random variables. Okay, discrete, think of it like a counting number. Okay, when we talk about the number of accidents, right, there could be 0 accidents, there could be 1 accident, there could be 2, and so forth. We cannot have, oh, there were 2.5 accidents, right? 2.5 accidents. Like, what is a half accident? So that's what discrete talks about. But sometimes decimals do make sense, like the lifespan of something, some sort of plant or something. It could live 2 years, it could live 1 year, or it could live 2.5 years, right? So that is a continuous random variable. Okay, let's look at this first example. So compute the variances of the 3 random variables with those probabilities. So we have, they're very quick. We have 3 different scenarios here, A, B, and C. And before we do variance, we have to compute the expected value, because if you look at the variance formula, it requires that we have these M's. Okay, so what the heck are all these A's and P's? Again, different books use different variables. That just stands for each outcome multiplied by its probability. Okay, so the expected value for A, E of x, we get take the outcome 4 multiplied by its probability 0.5 plus take the next outcome 6 multiplied by its probability 0.5. Okay, so 4 times a half is 2, 6 times a half is 3, so we get the expected value is 5. Now, really quick before we move on, say we were flipping a coin and one side had 4 and one side had 6. 50-50 probability for each, right? The expected value is like, well, after we do this, infinitely many times, what would we expect? Like, what is the average, right? Well, we would expect a 5, but that's not even possible here, right? You can only get a 4 or a 6. So sometimes it doesn't quite make sense of the problem, but overall we know, kind of looking at it, right, if they have a 50-50 shot, the average, which is not quite not exactly the same as expected value, but close, is 5. Okay, so the variance now, that says to take each outcome, so take 4, subtract the expected value, square it, and then multiply by the probability. Okay, take the next outcome, subtract the expected value, multiplied by the probability. Again, in this case, we only have 2, so nice and easy, but 4 minus 5 is -1 squared times 0.5 plus 1 squared times 0.5. So that's 1 times 0.5, 1 times 0.5, so we get 1. Now I know this problem doesn't ask for it, but the standard deviation is just the square root of that variance, so we also get 1 in this case. All right. For B, okay, same steps, and let's compare the outcomes that we get here, all right? So e of x, I might do a little more work in my head, but 3 times 0.5 plus 7 times 0.5, so that's 1.5 plus 3.5, we get 5. Okay, the variance, we do 3 minus 5 squared, whoops, not negative 3, just 3, multiplied by 0.5, plus 7 minus 5 squared multiplied by 0.5. Okay, 2 squared is 4 times a half is 2. 2 squared is 4 times a half is 2. So we get 4, and therefore the standard deviation, again, I know it's not asking for it, is the square root of that. We get 2. All right. For C, the last one, expected value, we have 1 multiplied by 0.5 plus 9 times 0.5. That's a half plus 4.5, we get 5. Okay, variance. Oop. Take each of the data, subtract this expected value, so 1 minus 5, square it, times 0.5, plus 9 minus 5 squared times 0.5. So that's 4 squared is 16 times a half is 8, and then same thing here. You don't always get the same thing, it's just the way that this one was created. Alright, so we get 16, and the standard deviation then is 4. Okay, square root of 16. Alright, looking back at this data now, like, what does all that mean? So notice they each only have 2 numbers, right? 4 and 6, or 3 and 7, or 1 and 9. But notice the spread of the data. The 4 and 6 are pretty tight, right? I mean, they're only 2 away total, where the part B, 3 and 7, are now 4 away, and C is 8 total away. They all have the same probabilities of a half, but the data is more and more spread out. Okay, that is what the variance and standard deviation is referring to. Now, later, standard deviation, we can make, in my opinion, a lot more sense of it. It's a bit more meaningful with the data that we're given, opposed to variance, but still, even with the variance 1, 4, and 16, right, I know that this data is spread out a lot more than the first set. Okay. Let's go back to the second example now. The number of accidents per week at a busy intersection was recorded for a year. There were 11 weeks with no accidents, 26 weeks with 1, 13 with 2, and 2 with 3. A week is to be selected at random, and the number of accidents noted, let X be the outcome. Okay, A. So X can only be 0, 1, 2, or 3, right? No, in that year, there was never more than 3. So part A, write a probability table. That's just talking about, write something like we have here. Doesn't matter if we go vertical or horizontal. I'm going to go ahead and just go outcome, probability, this way. Just get kind of the layout of the screen, really. So the outcomes, we can have 0 accidents, we can have 1 accident, we could have 2 accidents, or 3 accidents. Now, if we add these up, it should be 52 weeks in a year, so 11 and 26, 13 and 2. Yeah, we get 52. So the probability of having no accidents, there were 11 out of 52 of those. Right? The probability with 1, there were 26 out of 52. And then 2, we had 13. And 3, we had 2. And these definitely can be reduced. Sometimes we don't, though. And the reason is as we do operations on these, we already have an LCD, right? And it's somewhat more meaningful here. Like 26 out of 52, right? I know that's one half, one out of every two, but out of the 52 weeks, I get 26, right? So up to you. But let's look at B and see why maybe it's best just to leave it. Okay, EVEX. Take each outcome, multiply by its probability. So 0 times 11 out of 52, plus 1 times 26 out of 52, plus 2 times 13, 13 out of 52, plus 3 times 2 over 52. Now notice the LCD. So when we add these, I could do 0 times 11, which is 0, I don't need it. 1 times 26, plus 2 times 23, which is also 26, plus 3 times 2, 6. And we get 58 over 52. And if we were to use the calculator, we get about 1.12. So what does that mean? Part C says interpret it. That means like on any given week, we can expect 1.12 accidents. But I mean, there cannot be 0.12, right? And that's where expected value, it gives us somewhat of an average, but it doesn't necessarily mean we could expect that, right? It's just overall, we can expect an accident a week and a little more. So, have an accident one week, maybe 2 the next, and then maybe 0 the next, right? I mean, any given week, expected 1.12 accident is how we would interpret that.